mic needs to be in a container so that it works consistently every presentation, right? So awesome sessions in the morning. We had a couple of from Ponappa and the other guys, so awesome sessions. And I think one key takeaway that I was trying to see from those sessions was the culture change, right? And no better person can see that or say that coming from IBM with such a long history of work over there. And we are seeing tremendous culture change, not just within the company like IBM, but also with our customers. What we are here, so myself, Hariharan, although as Aditya mentioned, my hobby is to sleep, but I think with technologies moving, spearheading faster than what we could think of, I think I'm getting less sleep than more have to do work. So I have my co-presenter with me, Anu, who works as part of my team. So what we both together have endeavored upon within IBM, particularly with the group that we are working on, which is the middleware group, more from an enterprise perspective. I think a lot of talk has been going on, and I think most of you are from startups and other things, but we are from a sort of a varied background where we have worked with larger enterprises. Most of them are quite sensitive in terms of banking, insurance, retail, and so on. So we wanted to pitch in from that aspect and that perspective, and how do we look at DevOps from that perspective. And a lot of it, it's a journey that we have just begun. Sometimes I feel that, okay, we are somehow late into the marketplace in trying some of these newer technologies, but nevertheless we have started and we are doing some significant progress there, which is what we wanted to share today. So the topic that we have picked up today is basically to, as you could see, speed up the functional tests, right? So how many, just a quick show of hands, how many in this room are real testers? Cool, okay. And the rest of them, I could assume they are developers, apart from few hires and other things. All are developers, rest of them? Operations, okay. Yeah, we had that debate of, should we mix these roles together or whatever. So that's good. So as I said, I'm coming from a middleware background. So right from the beginning of my career, this is the chart that I'm used to it, where the kind of a pattern that we see in our customers' place is, you have an client. It could be a browser, HTTP client, sockets, or whatever. And then you have an app, which is where you write the business logic. If it is a banking, you will do internet banking or whatever that core meat is. And then you will work with the data, right? So this is a typical 3-tier client server or entire architecture middleware pattern that we see, right? But actually, when this middleware gets deployed onto the production system, right, the requirements started to pour in back to companies like IBM or other people who maintain this middleware. Usually, the application requires a sort of a runtime to run so that these applications can be scaled, monitored, managed, lifecycled, so on, because these are all the essential characteristics that middleware as a platform that brings to this application, which in today's concept we call it as a platform as a service, right? Which just runs on top of the infrastructure. And the stuff that runs under the middleware, there are plenty of operating systems that our customers would like to use. Some of whom were already using certain platform, they would request us to support our middleware in that particular platform, right? So there are varied number of choices that our customers embed on us to say that, okay, does your middleware support this? I want my app to work with this X software or a Y software. And so the middleware is sort of a complex architecture where the ecosystem of that middleware is humongous, right? And you can imagine the kind of a testing that we need to do within our middleware group to get all these things certified. Because at the end of the day, I cannot just tell the customer that, oh, we tested it in DB2, it's working fine. Oracle, it should work, but we don't know how that is because we didn't test it properly, right? Customers don't expect that to be done.
Just to add to this, so this is about the infrastructural complexity which Hari mentioned. There is the running complexity where the customers want, the banking customers, they'll say that I want the transaction per second rate of 1 million transactions. At least 1 million TPS has to be achieved by your middleware. Or customers like who are running large stock exchanges or trading companies, they'll have very tight SLAs that my transaction should finish in this much time. So the moment I hit buy stock and the moment transaction completes, it shouldn't be that the stock price has changed, right? So all this incorporates the running complexity as well. So
thanks, Anu. And just to keep the charts clean, I mean, you're just seeing the minimalistic components of the ecosystem around the middleware. It's actually, it will look even more uglier if I start adding all the components that we support around this middleware. And that's where, we say the testing for any middleware product is kind of a hell, right? I hope you're not able to read the things in the behind because you cannot read it. And that's because those are all the scenarios that we end up using during our system integration test or the functional test, or sometimes even in the build verification test, right? So these are the many scenarios that we need to cover to get our product certified with each and every supported product that we claim that is certified, right? So you can imagine the amount of time that we have to spend and the amount of QA engineers that we need to hire and also the developers to get these things end-to-end tested. And that's when we were thinking, and just before getting there, we also thought from a developer's perspective, right? So middleware testing is not always about the QA. So it's all now together, DevOps. So we need to give fair attention to these developers as well. And that's where we thought developers should be able to do some of their regression tests right in their laptop, which otherwise today the way it works is a developer comes in, he works on a problem, he checks in the code into one of the source code control repositories, and then he just commits the change, and then there is a nightly build that kicks off, right? So if I check in the code in the morning, I need to wait literally for the next day to see how my build has or how my changes have gone in and whether those verifications, the test cases have been passed or not, right? So it's a long delay. And of course, with the complexity that the middleware brings in, the amount of configurations that you need to do across that ecosystem with that middleware is humongous, and you cannot expect every developer or even sometimes every tester to know how to do that. So our goal or our objective for these developers was essentially, we want to provide an environment where they could pretty much do everything in their own laptop or in their own machine, and the ability to get an immediate feedback about the changes that they have caused into the system, right? So that is the change that we wanted to bring in some of these enterprise cultures. And to begin with, this is something that we are starting from the team, but as we go forward, we wanted to, propel this to our customer bases as well, and we'll talk about some of that later. I think I don't need to mention the bullets there, but typically the stuff that developers do today in an organization like where we come from is we use a shared resource, right? And developers are far more willing to install the latest update, sometimes going more than what is being certified by that particular middleware product, and end up doing certain regressions, and that is causing a different change, and that's causing a different problem, and then you realize that, oh, okay, developer had upgraded to the latest level, and hence he is causing the problem. So there are a lot of contamination that happens in today's, the developer's machine, for instance, and we wanted to get all that isolated, right? So here's a life cycle of a product's developer day, particularly if a problem is reported by a test folk saying that, okay, you caused some problem, right? What today happens is the developer has to identify a machine or an infrastructure, either on the cloud or most of the time. By the time they come to that investigation, they might have lost the context of what problem they had originally, right? So we wanted to get rid of these redundant tasks, and we wanted to provide them with an environment where they can do away with all these things. So, okay, something got screwed with my chart. So as I said, our goal today, with the way we run tests for our middleware stuff, it's pretty much silo. It's like one big monolith, sequential, like the gentleman showed in the morning, where you have an assembly line going, and if something fails, then the rest of the tests are blocked. It's pretty much in the same model that we were operating in the beginning, and this kind of takes a lot of time. In our case, it's close to 8 hours. 8+ hours is what we really need to get the feedback for any change that is caused by the developer, right? So certainly our goal is to reduce those hours into minutes, and the way we have done that is by splitting across those functional test cases into multiple jobs or multiple batches, right? And there are a few considerations here. One of the things that we hit upon the problem in the very beginning as we were splitting, because it looks very common sense, right? I mean, if you have one big monolithic thing, just split it up, just run parallelly, and things should improve in terms of the response time. But we got a lot of surprises there, primarily because the data that we were working with, right? We understood that there are a lot of dependencies that each of these tests have with the data that is resulted because of the previous test, right? So there are a lot of test dependencies. So we had to really go and figure out those dependencies, then isolate them, and then make sure that whenever we run each batches, they don't necessarily depend on the data or depend on the changes that was done by the previous test as such. And then we could then run it parallelly. So through this method, we sort of reduced the hours to minutes. It's still not around the ballpark that we would like it. I think now it's close to 30 minutes or something, but we still need to do a lot more in that space. And other thing that to notice, what we have done is for each jobs, what we made sure is we have the fresh data allocated for each jobs as they enter executing the test. Right? So they all know what kind of a data set that they need to expect when they run these test jobs, so that it always works in a consistent way. Because we have seen, I mean, to begin with, we tried making sure that, okay, it's always good if some test leaves some data and if another test can pick up that particular data and start working with it. But we had a lot of issues in terms of inconsistencies, and we took a call saying that, okay, let's let all the tests fairly run with their own data set, which are created freshly, and then it was more consistent. So there's no magic here. We just used Docker. So we basically created as many containers as possible that could suit our test cases. So we parallelized our functional test by running parallel or concurrent Docker containers, which constitutes of all our test cases. So we roughly had around 4,000 test cases that we split into the buckets of 9 to 10 components, and then that sped up a lot of response time for us. Why we chose Docker? I think just prior to onboarding to Docker, we were literally using virtual machines. There were a lot of, like, say, KVMs or the VMwares, and we saw that there's still a lot of heavyweight lifting that we need to do in terms of configurations and setting up those virtual machines. Docker, on the other hand, provided to be much more lightweight, and it was much closer to what we wanted to achieve, which is basically to give a developer or a tester an environment which is closer to, or the one that mimics our customer's environment. The other thing that it helped us provide is the version control. Many times we get into this problem. I'm sure many of you would have probably as well. Fag end of the release time, we used to hit some performance issues saying that, okay, we degraded by X%, say 10% of performance SLA has been dropped, and then we backtrack and see what changes caused that particular performance problem. And that backtrack is actually a very painstaking issue, because you don't know which defect has caused that problem. We don't know which developer or which change of that developer has caused that problem. So what this version control has helped us achieve is that we could actually monitor each of these images. As in when it gets created, we can tag them, and then we can just see which of those images can run through this performance test, and then figure out which of those images have actually caused the performance drop, and then identify that particular bug or whatever, right? Other things are much general, specific to Docker. Would just like to call it out. The other thing that we were looking at is the resource footprints. So the bots on the left is basically a single core machine. So if you order an instance from Amazon or Azure or Bluemix, you will end up getting a single core as the lowest configuration. And on the right side, you have a dual core configuration or a virtual instance, and the two boxes inside that represent our stack, right? Our full stack, application stack. So the bots in the blue is essentially the application that denotes the application, and the one in the orange denotes a database tier where the application works with that particular data, right? And if you end up having the same stack in a single core machine, which you could possibly can, but what we have seen is it kind of strangles and competes for resources, and more time is wasted in doing context switches as opposed to doing the actual work. And if I take a case of having such resources, say 5 virtual instance resources, and if I just put on my stack, right, this could easily work, but we realized that this might not be as efficient as we think. So what we did instead was to do something like this, where I could have 5 of those applications configured in each of those virtual instances. So you could see the 5 blue boxes. So each of them are running in an individual core. And then you have a database tier. As the load could be more from these applications, we could just have it in a different instance. So what this sort of gave us advantage is that it gave us enough room. As you could see, there are 3 empty boxes or empty cores which are not doing anything, and that gives me an additional 60% capacity to leverage other testing that I wanted to do with this middleware. So the Docker, and in conjunction with the CI tools, in this case the Urban Code Deploy that we were using, we were able to deploy the applications in such configurations, and the interactions across these virtual instances happens through the internal network. The containers to containers talk through the network as such, and then we get the added additional capacity to do more. Yeah.
This is, thanks Hari. So this is the method we use to create our Docker images. So we have a Docker file which will actually first of all do some pre-install setup, take the system resources, whatever, because it's a complex middleware and with large resource requirements. So we'll take some special like shared memory, semaphores, etc. We'll take those system resources. Then we'll do the installation and post-installation steps. After that, the Docker image which is created is a complete stack of all the components which Hari showed in the beginning of the architectural diagram. So it will have the gateway product, the middleware product, the web product, and on the top of that there will be other stack components like language compilers, the runtimes for other applications, and on the top of that we'll have all the functional test packages. So once this image is created, we'll next slide. So we'll just create the containers from that image. So this in this step we have a script which will parallelize creating the containers. So those depending on how many components we want to run in parallel, so that script will spawn that many containers in background. Those containers will run their own test suite or test component, and then a separate container or separate image we create for the data and log volumes. So we'll call that as, let's say, volume container. So it will have all the data from which the test containers will pick up the required data. So as Hari had mentioned, we parallelize the data. So we are not so that had to be made independent to parallelize the tests as well, right? So once we parallelize this stuff, all the containers will actually write their logs into the log container. And then there will be a result aggregator script which will pick up the logs from that log container. So there we use Docker volumes to communicate between data and log containers. And that result aggregator will aggregate all the results, and that can be shown by a front-end API or web tier. So this, yeah, you can explain.
Yeah, and then as Anu mentioned, once we stacked that up, once we had those parallel containers running, we realized that we had monolith kind of a container where all our application stack was running inside it, and then we suddenly saw a shot up in the CPU percentage on the host that we were running. And then we realized that we didn't have to have such monolith containers running in parallel stuff, and we know very well within middleware and our ecosystem, and we sort of broke that configuration into various services, right? So we have database, we have messaging system, we have other enterprise system. I could just treat every one of them as a service which runs individually in a different container, and our application can then interact with that particular container as and when it requires those resources. And then I could then scale up each of those containers independently depending upon our requirement. For example, for performance, I could have a different criteria. For functional test, I could have a different criteria. So all this we did with the help of the Compose. So as you know, Compose helps us to orchestrate these containers with which we could just bring up the entire topology with just a single command of Compose up. And then we could also scale with a single line of command to say which tier, whether the app tier or the database tier that you wanted to scale up. Just wanted to show a quick preview. I mean, it's quite elementary for now because we don't have the SoftLayer connection here, but it's basically running out on my laptop. So basically, I have a Docker installed on my Ubuntu machine here, and we have a script that says parallel test.sh, which basically takes up all our test suite components and then spawns up containers. So I could just run some parallel container jobs, and you could see that and you get the container IDs, and then we get the exit codes once the container finishes. And then I could just, as Anu mentioned, we just create a log volume in the host. So that's pretty much this directory. And I think once it completes the run, it's supposed to do the result aggregator. Saying that, okay, these are the number of tests attempted, passed, and it indicates a component, so on, just to give a feel of what we have done so far with this work. And we have a SoftLayer environment that's fully fledged with all other test suites as well.
I think thinking that why people just speed up in the end of their presentation, and the stop clock is actually blinking like anything. So you have to actually speed up quickly when your time finishes.
We not only brought down the number of hours from 8 hours to 30 minutes, but more importantly, we had a lot of servers on-prem, and they were all running less than 10% of utilization, CPU utilization, as well as memory utilization, with all our functional tests running on it. Right? And we could get that with all these Docker setups going, we could get that up to 80% utilization. So we have better utilization of our servers. We have a lot of other spare servers that we could use for development purpose and other creative stuff that we do at the work there. Now we have these containers created, images created. We have a private hub or a private registry where we publish all these images. And we need something to continuously do the same step every time a developer checks in a code. So what we did is we used the IBM Ubuntu code build, which basically creates based on the Docker file, it creates an image, and then once the image is created, it publishes to the registry, which is a private registry for the team, and then it notifies the Arbon code deploy, which just goes and deploys all these containers in a parallel fashion, and then it just emails the report that I just showed you to the developer, right? So it's basically trying to make the entire process more seamless. We ran into some of the challenges, like for instance, every time we didn't have, the same version of Docker file was not helping us, because for certain type of testing we had to use different versions of software, like say for example one of the Perl that we were talking this morning, it doesn't work for some reason in our performance test suite. So we had to make sure that we had a different version that was identified for performance test suite versus the functional test suites, right? And so we had to create multiple set of Docker files and then manage them through the source code repository, right? And sometimes for us, with the Docker file, with the kind of ecosystem that we have with the middleware, it takes humongous time to create an image itself, right? In some cases, close to 20 to 30 minutes to create the image. So in some of the cases, we had to go and say no to Docker file. Rather, we just focus on the basic imaging concepts, create that image with the necessary configuration and software installed, and then use that as a base image to build up the other applications and so on. As we move forward, so one of the things that Docker gives a lot of benefit that we were just discussing, but moving forward for our customers who are already having an enterprise applications running in their own data centers, one of their key requirements is to see how we can build enterprise grade values on top of these Docker technologies. And that's where IBM came up with this IBM container, which was recently announced back in June, where we add a lot of value on top of the existing Docker system. The IBM container is nothing but a technology that is built on top of Docker, so you literally get all the values and features of the Docker on it automatically, but we also build additional features on top of it, especially to aid the enterprise users. For example, if you look at, we have the image scanning technology that ensures that the images that you're downloading is sort of secure, and then you have a private registry, elastic scaling, and containers are also used to deploy directly onto the bare metal as opposed to any virtual instance or any other OS, right? So it brings in some of the added values that containers, and we are actually hoping to get our tests done on all these containers right from our laptop, so that all of our performance and functional test happens at the IBM containers, which essentially runs on top of a Bluemix platform. And Bluemix, if you are already not aware, is essentially a platform as a service offering from IBM, which is basically a technology on top of Cloud Foundry. So at IBM, we value a lot of open standard technologies, and wherever we possible, we build on top of it, giving the additional value that our enterprise customers that we usually work with. A lot of lessons learned in this exercise. I think Anu has been extensively working on this. I would just let her look at and go through some of these.
I don't want to remember all the time I spent there. Yeah, so there were a lot of lessons learned, and more things which we think we want to explore further. So as Hari was mentioning, building of Docker images was taking too much time, and every time, because this is about functional testing, so almost every day we need to build a new image with the new release which comes in with the previous checked in code. So we can't afford to spend even like 15 minutes, right, to get the image built and everything, 15 to 20 minutes every day. So what we thought of, that we'll break the image into the static components which hardly change, and the dynamic components which most frequently change. And one of the best facilities I felt Docker provided was this layering of file system. So after that breaking up, we were able to get the image done very quickly in maybe 1 minute or so, because only those layers were getting built which were the dynamic ones or changed ones. So that was one thing. Then Another thing was that we were facing issues with the things like shared memory, semaphores. So after figuring out and a lot of investigation, we figured out that Docker, when you create a container, so it doesn't immediately get the same resources, same resource limits as are there with the host image. So we needed privileged access to get the same amount of shared memory or semaphores or all such resources to work with our kind of workloads, like large workloads. Right, then the third one was the IP address allocation. So when you create a container, Docker gives that container a different new dynamic IP address. But our applications and test suites were such that they were supposed to be working with a fixed IP address. So they would interact with each other with database and with client, and there would be a server application listening on requests. So with every container getting a dynamic IP address, we would have to either create script which once the container gets up, it figures out what's the IP address of that container, and then only it will update that functional test to use that IP address. But that was again not very optimized way. So that was involving some scripts and other stuff. So we want to explore how to make that change from dynamic to static, so that we involve lesser manual interaction there. Then coping up with version inconsistencies that Hari has already mentioned, that how we were using a lot of changed versions. So we were supposed to figure out at the end of the build almost that the performance cycles were being done at the end of the release. So there we wanted to see, once we would run performance tests, we would figure out, oh, 10% degraded, 14%, what happened, which code degraded this. Then we would have to again roll back. So there Docker helped up a lot in figuring out, like we would create the Docker images and we just need to run middle points of the Docker images and see that which image or where exactly the performance degraded. Maybe it was in bunches, or maybe just one change brought it down to 10% and all. Other kind of version inconsistencies are related to the packages, the package changes which different test suites need. So all that I felt that Docker was very easily able to cope up with that in terms of as respect to other solutions like VM or that way, right? So finally, container upgradation process, like we need, like Hari said, we are running a lot of containers. So from management and tooling perspective, there we need to still explore how we can figure out which containers we are running, which container is running which tests, and which one we need to monitor, and which one we need to speed up better to get overall efficiency in the entire process. Sorry, you want to add more?
No, I think the one aspect that we found there was as the developers continuously checking in their fixes, we had to ensure that there is a pipeline of containers that gets restarted automatically with those changes in. So we need to pull up a new image, and then we need to stop those containers and then restart those containers with a new image. So that is sort of going manually, so we need to build some sort of a management or a tooling layer to make sure that process is also seamless. So that's other pain point that we sort of had. So when we began the journey of exploring this automation and parallelizing the functional test, every time we ask a developer what's happening, then they just say, I checked in the code and waiting for the result. And to now, where developers saying that, I have checked in the code and waiting for the Docker image to get built, right? So hope we kind of make those changes as well to make it more seamless, but that's the current state we are in. So in summary, just to conclude my talk here, where we basically say Docker has helped us a lot in terms of giving us a consistent stack to our developers, where they can rely upon doing the changes and getting an immediate feedback of the test that they would like to do on top of their changes, including the performance test. And what we've also figured out that it gives a solid foundation to prevent the regressions, as well as some of the nasty feedback that we used to get towards the end of the release cycle. As our middleware is kind of a broader scope, usually we spend 6 months of time just doing testing after all the developers have just came up with their changes and everything, and 6 months we just do nothing but testing. And we are hoping that through these changes, that 6-month cycle would probably reduce to a month or lesser than that. And that's a big thing for us, because speed to market is crucial, and that's where DevOps is playing a huge role. And as we develop features, we need to figure out way out to validate that quickly and pass it on to the customers, who could then benefit from those changes and be productive for them. Right? So that's all that myself and Anu had. Thank you, and if you have any questions, we could take that up.
And so what are the middleware application service that you have already explored for? So what are the products that you have already ran this test for, like WebSphere application server, portal server, commerce server?
So we began with our own product called TH series, which is the non-Java based application, C, C++, COBOL. But we have also done it for the Liberty, which is a lightweight edition of WebSphere. So these are the two middlewares, and we are still in the process of evangelizing this within our company to bring in more middleware aspects to this.
Because even I know even the Bluemix, they support Liberty, but not other core products like the application server, ND or portal and commerce servers. So I'm just curious how easy to explore the same Docker for these products, because they're very heavy and the maintenance is huge. So I'm just curious, is it possible? Or
yeah, I mean, it certainly gives us the flexibility to bring up images for such topologies for the WebSphere, ND, and all that stuff. But yeah, I do share the same sentiment of how heavy that would become over a period of time, which is probably where we started with Liberty, which is sort of a lightweight container to begin with. And just, I mean, part of the Docker work that we have been doing here is trying to see how minimally we can get started, because Docker provides a lightweight OS, and if we start bloating that up with our own product, then it just loses the purpose. So we had to change a lot of things from ground up, which, to be honest, it's very difficult for a product that has been there for over years. You have to literally throw things out, and that requires a lot of culture change, right? And yeah, so we had to do all that stuff to make it more lightweight, and only then we would see this benefit. Otherwise, it would just become another virtual machine. Yeah, thank you.
In the present demo, you demonstrated how you ran tests in parallel, right, by running a script. So, but in real life scenarios, you don't actually run a script to run your tests, right?
Yeah.
So, how do you do that in using Urban Code, or Urban Code is a part? Is it a part of Bluemix or what?
No, I mean, we have a service in Bluemix. Now, pretty much everything that IBM does, we have a service on Bluemix to be consumed as a service. But yeah, IBM Urban Code Deploy is a product. It's an IBM software product, which helps you to orchestrate these containers and deploy these containers in an automated way.
So is it like deployment pipeline with image
Exactly.
As a service?
Exactly.
Okay.
And then there is a feeder to that, which is basically the IBM Urban Code build, which takes care of building those Docker images and then feeding it into the Urban Code deploy. And deploy then takes care of deploying it in the infrastructure and getting the feedback. And hopefully at some point we should see a HTML kind of a page to see the report rather than running through scripts. So that's a work in progress for us. But whatever we just showed is basically the initial stuff that we have done within the project.
Hey, this question is problem. Do you have any?
Yeah, so right now, as I was mentioning, that we are still exploring on trying to convert it into static. So what we did was that our client daemon in the configuration file was supposed to put the IP of that container, and then servers would pick that IP, and then that's how they would connect with each other. So right now we are using very basic methodology. So as soon as the container starts, a script is spawned, we showed with the background option. So with that itself, we trigger that script is triggered through that background option, which picks up the IP address of the container, adds it in the configuration file, then starts the client. So, but that is, as you can see, some amount of time lag is there. So we want to, we are still exploring how to eradicate that.
Okay.
Yeah.
How did you achieve effective parallelization by, you said that you had a large monolith and they had many dependencies in the tests. In the monolith, it's very easy because you can just order the events and you can have the tests go from 0 to all the way up. But in parallelization, you have to break it in a way so that the dependent tests do not stop. So how would you do that?
So fortunately for us, in the middleware that we are working, most of those components are already componentized in the sense that we have a larger ecosystem, like say we working with DB2 or MQ. They are already split up into different test cases. But what we had to ensure was the data that they work with. There were a lot of interdependencies across these components where one test starts off and then it writes some data, and then the next test, as soon as it starts, it expects those data to be in line or in sync with whatever it was finished earlier. So getting rid of, because if I have to parallelize this task, I cannot literally parallelize because I need the state of the data that the previous test finished at the time of finishing, which I need to feed it to the next test. So those are the dependencies that we had to sort out, and the way we did that is we understood when a test finishes what kind of a data it would leave the system with, right? And we just use that state or that particular data as a feeder for the other test to begin. So we had to write a lot of scripts to populate the data directly to the database so that when the test begins, they know that, okay, this is the proper state that they have to start up with.
So which means you cannot have a variable called parallelization equal to 5 and effectively achieve 5 parallelization.
No, not for a general testing scenario, because it all depends on case to case and how your test cases are built. If there are certain intricacies and dependencies like this, you cannot just say parallel equal to 5 and expect it to fire. No.
So is this dependence, so this dependence is when you're talking about, so do you have an aggregator script who gets all the results and so he has to wait for all of them to finish, right?
At this moment, yes. So we just do a Docker wait to wait for all the containers to finish. So that the idea of the Docker wait there is to see if I can get a consolidated set of result back to the developer as opposed to sending test results based on every test suite or test group or test job. So that's why we just wrote a result aggregator script which waits for all the containers to finish, which are anyway running parallel. And once everything is written, every container will write to a separate log about their test results, whether it's passed or failed or whatever. And the result aggregator will just going to pull up all those files and then put it in a report and send it to the user.
All right, thank you.
Yeah.